Okay, all right. Okay, so good evening, good afternoon, all. So today's session is about sentence transformers. So it's most important topic for understanding how AI works. So after this sessions, you mostly clear so behind the scenes, like behind the Chat GPT or Gemini or any AI models, how exactly it works. So you'll understand this part, and you can do more stuff like small stuff without even AI. Okay, so today's session is more about the technical session. So I have not prepared any PPT. So I'm directly going to give some examples, directly execute the code and show you how it works exactly. Okay, all right. So let me share my screen. Okay. So sentence transformers is basically as you know, the computer mainly understands the numbers and not any text. So that's why we have like when we have type some characters, behind the character there is some encoding, like there is some numbers, right? So we have like a lot of encoding techniques as well, like UTF-8 is the modern one, and then all other olds are there. So behind the scenes, like computer understands only numbers. So so text, like earlier, so when we implement the searching algorithms in database, we used to have some techniques that will basically counts the words, number of times that words is counted, and based upon that, those search techniques are working. So in this sentence embedding or sentence transformers, so basically it gives more benefit because it just not encode the words, but it encodes whole the sentence. So it has the context, as you like most of the Marathi people knows that the in Marathi or maybe in Hindi as well, there are some words that has different meanings, and that meaning change based upon their context, right? So to encode these whole sentences, it gives some numbers. That numbers is not understandable by humans, but yes, it's understandable by computers. So those numbers are basically is given by the pre-trained models. So those models are basically uh, models that is used for the NLP, natural language processing. So here we are using for today's demo, will be using this sentence transformers library, Python library. So let's begin and we'll go one by one. So in this today's topic, we'll cover this sentence embedding. So I will show you all these points: sentence similarity, semantic search, and clustering. So we'll see this one by one. So first, before starting, we have to install this library. And then next thing, we need to import this library, these two functions that we need mainly. Let's wait to finish this.
So Datta, what are we downloading?
These are the libraries, like the sentence transformers library. This is downloading on cloud. So this is basically Google Colab tool.
Okay. It's on GCP right now?
Yes.
Okay.
Okay, and meanwhile, I will show you. So basically, we have all these pre-trained models. Let me know if you are able to see these models. Okay, here are different models that we can use for our purpose. So for smaller purpose, for English, maybe you can use these smaller models. Like it has just 80 MB model. And if you want like multi-language, maybe in Marathi, Hindi, So we can use multi-language models as well. And even for our own context, we can pretend models as well. So we can fine tune our models, own models with our requirements. So we can, by taking any base model that is suitable for us. Okay, so let's see. Okay, so it's done. So for today, we're going to use this all embed base V2 model. So this is like a good model that we have. So basically right now this is sorted by their performance. So I found this is good work, but it has also like 420 MB. Okay, so let me install this model as well. Okay, all right, it's installed. So now next step. So to encode the any text, like array of text or maybe simple text or maybe parameters, so we can use this model. So I have used here model, and with this model we can encode our text. So I have two lines here, like I love coding, so I hit A. Okay. So when we execute this, you will see this random numbers. Okay. The sentence is I love coding, and the embedding that we come up here is all these numbers. And we have this like line, and for this line we have this another matrix. So generally this is called embeddings, or we can call it as a vectors. And the vector has dimensions. If you see here this number, this is the dimensions. Uh, uh, with these dimensions, this model has trained. So it produces all the encodings like 768 in 7068 dimensions. So all these numbers are basically, if you count the array length, so you'll found that this will be a 768 numbers in this array. So dimensions is basically we have this text, right? So this text can be we can see like different meanings of this text. So based upon this whole sentence words, it produces a numbers based upon that model. And basically we generally see 2 or 3D dimensions only. So that's why this is not readable by humans. So next we can find the similarity. So here I have 3 lines. So for example, here I love eating apples. Okay. And then I enjoy eating fruits like apples. We have 2 similar lines, but if you traditionally compare the text here, the Apple is releasing new iPhone. So this is like something different, right? So these 2 lines are maybe similar, but the third line is not similar. So let's check the results. Okay. So this cosine similarity, if you compare like 2 first lines, then you can see the similarity. Basically, this number is between -1 to +1. So +1 is exact match, and the like lowest number is like it's not matching. Oh, it's far from the match. Okay. So we can see here this number is like closer to 1, and if you compare this one first line with third line, and then see the difference. The number is like very low, like it's not closer to the matching. Even it has this Apple words here, right? This happens because the model knows like this line is different. Apple is a like food, right? But here Apple is containing the fruits. So why this is closer match? Because it's apples are fruits, it is like closely matching. So similarly, we can see this matrix. Like we can use these applications to find the closer uh, sentences, closer match. Okay, so here I just compared all these lines with each other. So here we can see the Virat Kohli scored a century in a cricket match. So when we compare this with same line, so it exactly matching one. And the second line is the Indian football team on their final game. So this is like 0.38. So if you see others, it is like good number because this is something related to sports. These two lines are something related to sports. That's why it's matching each other. The other lines are having lowest number because uh, they have different context there. So similarly, all others are compared here. Indian football team on their final game. So it is closely matching with the first line. Second line is exact match because it's same line. Others are having some lower scores. So
That's the one question.
yes,
Go to the first line. Okay. So here, no, go down where we compare the first line with all the other lines. So
yes,
here, Virat Kohli scored a century in the cricket match, matches with the first line completely, and that's why it's one.
yes,
Right?
correct. Yes,
I understand that the second line, Indian football team won their final game. So it matches a bit because both are related to sports.
yes,
Now the line regarding Bollywood, a Bollywood movie is being filmed in Mumbai.
yes.
How so? It has the next best match. So how is it related to Virat Kohli scored a century? Is it taking the Mumbai link or how does it know?
Yeah. So basically, this is all based upon your model. So whatever model you choose, how it's trained, because of that it matches. So it's probably that Virat Kohli is linked with some Mumbai word in the model itself, or it is related to like Virat Kohli,
उसके
his
वाइफ
wife,
उसके
his
वाइफ
wife
की
is
वजह से
belonging to movie. So that's why it is producing like uh, similar results.
Hmm. And then that 0.25 as well. A passenger train arrived at New Delhi.
Virat Kohli century. Yeah, it's all depends upon the model.
maybe this is lightweight model and that are not more accurate
Hmm. Yeah,
because
just
like
trying to understand how is it related to each other, like how the cosine match thing works.
So cosine match is it's like it's matched on the numbers. So this encodings, these numbers.
Mm-hmm.
So these numbers are produced by models, and this is like simple mathematical match based upon these numbers.
Okay.
I doubt it's creating some link. It's basically just kind of word to word matching, right? No.
No, no, no. It
No,
has like
it's
full sentence.
not.
Okay.
Okay. So then at bottom, I have just compared the top pairs, top matching pairs. So if you see top three matching pairs, the students are attending the math lecture in the classroom. So his teacher is explaining grammar rules to the students. So if you see these two lines, this one and this one, these are something related to educational, right? So that's why it's created the pair. Then second, Virat Kohli and Indian football team. So basically, this is closest match. And then third one is the passenger train arrived at New Delhi station. So this is something related to travel. So another related closer match is a bus picking up passengers at the bus stop. So we can find similar words using these techniques. So then next thing where we can use is the semantic search. So this we can use in database as well. So like Ronak and we work on the Postgres with these embeddings. So probably we can use these techniques to implement the search from the databases. Okay, so let me install this model as well. It will take little time. So what we are going to achieve with this, like we have some questions and we have some closest like RAG, for example. So we have some similar, and we need to rank. So first we will rank and then find the closest answer. So here, for example, the question is how many models can I host on Hugging Face? And we have three answers here, and this will find the most closest answers. So what we'll do, we'll encode question as well as the answers, and we'll match with the semantic search. So it will give the rank results in a rank. So we can sort and we can find the closest match here. Okay. So here we have question encoded and then answers, and then we have scores as well. So the first is the closest match here, answer one. And to get the exact answer from this answer, like for example, for this question, how many models can I host on Hugging Face? So answer would be like unlimited, right? To get this, the transference model have question answering model, so this pipeline. So we can use of this model and to get the exact answer. So with these questions, we can rank and we can find the closest, and we can pass that closest answer to these pipelines and to get the exact model, exact answers from extract the exact answers from the uh, text. So let's execute this. Okay. So if you see here, the answer is unlimited. So it gives the start, the token text start index, end index, and the answer that is found from this model, from this answer. So we get exact answers as well. So we can use this techniques to extract the exact answers from the text. So the last point, clustering. So we have like a lot of statements, and we want to find out the closest or the similar. We can classify those similar statements. So we can use the machine learning techniques. So clustering is one of the technique where we can use. So again, clustering is, it will work on numbers. It will not work on text. So what we need to do, we need to encode this text into these vectors, and then we can apply these techniques to uh, apply the clustering, and then we can find the similar things with this cluster model. So what we'll do here, so we have this model. So we have this text, and we'll encode this text, and we'll see the cluster output. So let me include this. Okay, it's downloaded. Okay, so here we applying k-means clustering technique, and we will cluster like four different clusters, four different groups, and we'll see how many models that we have, how it is categorized different those texts. So it comes like here created 0, 1, this 2, and 3 groups, like, and we'll see now these numbers are basically index. So we'll find exact text from those index. Okay, so first cluster, cluster number 2. So it has something related to eating. Then second model, okay, probably this is not good result here
Yeah,
because this,
animals.
yeah, maybe this is categorized as a animal. Then second cluster, probably it's related to something horse or animals. Yeah, all these are animals. Third one is woman eating biryani. The third, the fourth one, something related to humans, I think. Yeah. So we can use any models that is suitable for us, or even we can create our own models. We can pre-tune as per our requirements because uh, these are like globally pre-trained models widely used. So most probably for English at least, or maybe for some multi-language, the pre-trained models are available. This will fulfill our problems, but if still this will not fulfill our problems, then we can pre-tune our own models as well, like taking any base model here. Okay. So any questions as of now?
So Datta, where can we use this?
So this mostly used in to extract the answers from the documents, to implement the semantic search, like Kunal's favorite PDF. You can find.
PDF question answer.
Yes. And this is all we are day by day using. Like so when we enter some prompt in the chat, so this basically encodes your prompt and it finds the exact vectors in the database and it produces the output. So basically, this text transformers, it is like bidirectional. So we can convert text into the numbers and numbers into the text as well.
Okay, so what happens like whenever we, let's say, I supply a document to ChatGPT or DeepSeek, okay, and then
Okay.
I ask a question that based on this document, please answer this. So in the background, it is doing this.
Yes.
Okay.
I guess even in the normal chat GPT, whenever we ask question, just general question, no PDF. That time also it do that
Yes.
sentence transformation.
Your every prompt
Yes.
that is encoded, like ChatGPT is trained, I think, in like with higher dimensions. It's I think more than 1200. And all other are it's around 800 something. So, so this dimensions plays the main vital role here because this is how the models are trained, so they can get exact context from this text.
Mm-hmm.
Guys, questions? नहीं है मैं पूछूं? I know no one is going to ask questions, so I prepared some questions list. So we'll discuss. It has questions and answers as well. Okay. So what is sentence embedding? So it is like vectorizing your text into the some numbers, and it is like full sentence. It is not just like a verse. Second question: what is difference between word embedding and sentence embedding? So word is a single word meaning, and sentence has full context. So why to use sentence embedding? So they capture context and meaning, not just word counts. How does sentence transformers work? It uses models like BERT. So this is the model. So it creates the embedding using these models that I shown here. So what are the common? Sorry, what is the pooling? Meaning CLS. Pooling combines tokens embedding into the fixed size vector. So it creates the fixed size vector of each sentence that we have. Next question, common dimensions for embedding. So example, like the lightweight models that produces 384 dimensions, and this 768, the current model that I showed in this demo, is using the 768 dimensions. As I said, ChatGPT uses, I don't know exact number, but it has more than 1200 dimensions.
So that the whatever may be the length of the sentence, it will always create a
Yes,
seven
same
dimension.
size. Yes.
So if I have a 500 letters long sentence or 50 letters long sentence, it will create the same dimension.
Yes, but again, it has some limits. Like model. So when we pass any text, it will trim the text because models are designed basically to accept some certain amount of text, not full. But yes, if you pass even one word or even pass you like 100 words, it produces same numbers, like same dimension numbers.
Okay.
Next question: does higher dimensions means better? It is not always. It depends upon our task, like because it's again depends upon the language that we're using. Uh, so all these factors matters. So what is correct way to choose the right model? So again, this is based upon your task, language, size, and speed that we need. So fine tuning sentence transformers. Yes, we can train our model based for our own requirements. So when we need to do the fine tunings, when default model doesn't perform well, so as we see this, some text are matching, even it has other context, right? So we can pretend our own model in this case. So what are the use cases of this sentence modeling? So to implement the search, similarity, clustering, so chatbots, keyway systems. So we can use these techniques. So how to measure the quality of embeddings? So using question similarity, clustering accuracy, and benchmarks. So as we see in this question similarity, so we can find out the uh, quality of the model that we are selected. So multi-language model, pros and cons. So multi-language model is good when we use the multi-language text, but since it has too much data, so that might be not correct for us if we have like single model. So this means that sometimes single language models perform better than the multi-language models. So effect of embedding dimensions. It impacts speed, storage, and sometimes accuracies as well, because we need to store all this data, right? So it requires the storage space to store all those vectors. Sentence transformers versus OpenAI embeddings. So whatever we see now, we can install all those libraries, and we can, in our own projects, we can use all those embeddings. Similarly, these embeddings, we can use ChatGPT, like OpenAI's embeddings as well. But yes, obviously, it gives you more accurate, more stronger dimensions. But yes, it is. We have limits. We need to use their API keys, and they have certain limits there. So visualizing embeddings. Yes, as I said earlier, so this produces like multidimensional uh, views, right? And human only understands 2D or 3D dimensions. So there are some techniques that will convert all those dimensions into 2D or 3D. We can visualize those text into the some charts or some maps as well. Okay, so I have all other questions. I'm going to share all those questions here. If you still have any questions, so please ask. So I'll try to answer here. If not, then I will share all this with you. So you can clone and you can play with this as well, on this code. If you have Python locally, then you can use same code in your Python as well. No questions? Yes? Yeah? I'm going to.
Datta, okay, just A general question, I guess, in the sentence transformation, the general, let's say a man is eating food, something.
Okay.
So transformation, I don't know where I remember this. The common statement like is the something like that. It's remove, right?
No,
So
no,
this is it. No
no. This was removed in the earlier
semantic.
yes,
Yeah. Okay.
those techniques. So in this,
Okay.
those are important because that has some context, right?
Mm-hmm.
Those are
Okay. In
not.
the semantic matching, it's removing, right? Because is the is not like that.
Yes.
Okay.
Any other? If not, then yeah. So I'm done here. Thank you.
Okay. Thank you, Datta.
Thanks, Dr.
Yeah. If you are still concerns, please raise the questions by mail or chat. Okay. This is very important, guys, because everything is going on the AI, right? So everyone needs to understand the exact how AI is working. So if you get those basic things, then you will get an idea on the future, the whatever the we will get the developments. Yeah. Thank you so much, guys.
Okay. Bye.
Yeah. Bye.